In this lesson, we are going to talk about electronic configuration writing in shorthand method. By now, you have finished the electronic configuration writing for elements using SPDF notation. If you know how to write the electronic configuration in SPDF notation, then shorthand method of writing electronic configuration is pretty simple. To write this electronic configuration, I first take one or two elements from the periodic table. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is helium. Oh, I'll complete the third period as well. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Right. I will take the electronic configuration for lithium. Before lithium, we have helium. Helium has 2 electrons. I'll write 2 electrons for helium. Its configuration we have written earlier. It is 1s2. If you go to lithium, lithium has 3 electrons. Its configuration is written as 1s2, 2s2. This is the electronic configuration in SPDF notation. SPDF notation. If I consider this SPDF notation for helium and lithium, just look at this. One S2 is an electronic configuration of helium, which is a noble gas. Helium electronic configuration is 1s2. If you go to lithium, here, lithium configuration 1s2, 2s2, it also has part of its electronic configuration similar to helium. You get it? Lithium configuration is 1s2, 2s2. Before lithium in the periodic table, we have helium. Helium configuration is 1s2. If I want to write lithium electronic configuration in shorthand method, then you go to lithium configuration and see it has 1s2 in its configuration. And I know 1s2 is a configuration of helium. So lithium electronic configuration is written in shorthand method. Don't start with 1s2. We know 1s2 is the electronic configuration of helium. Open a square bracket. Instead of 1s2, write helium. Close it and write 2s2. This is the meaning of shorthand method electronic configuration. How can I explain this? When you write shorthand method of electronic configuration, you have to check the periodic, you have to check the electronic configuration of a given element and see it has the electronic configuration. Again, I'll write, when you take an electronic configuration of an element, its electronic configuration has a part in it which represents the electronic configuration of its preceding noble gas. Preceding noble gas means noble gas which is coming behind. Not 2s1. Oh, I'm sorry, I made a huge mistake. This is not 2, 2s1. So this should be 2s1. Thank you very much. Okay, we make mistakes. Thank you very much again. Okay. This is the electronic configuration shorthand method for lithium. How do I do it? Always check the electronic configuration and find out, as a part of it, the electronic configuration of its preceding noble gas. Remove that electronic configuration and put the element helium noble gas and write the remaining electronic configuration. I'll go to the next one. Neon and aluminium. I'll take neon and aluminium. You know the neon electronic configuration? I write it first. Neon has 10 electrons. 10 electrons. Electronic configuration for 10 electrons can be written as 1:2, 2s2, 2p6, 2p6, yes. 1:2, 2s2, 2p6. Now I go to electronic configuration aluminium. Aluminium has 13 electrons. 13 electrons. 1s2, 2s2, 2p6, 3s2, remember the other one, 3s2, 3p1. Right. It's very clear in this. Neon electronic configuration is 1s2, 2s2, 2p6. The same electronic configuration is there as a part of the electronic configuration of aluminium. See? So how can I write the electronic configuration for aluminium in shorthand method? Aluminium shorthand method is equal to, don't write 1s2, 2s2, 2p6, because that's the electronic configuration of neon. So you write neon. After neon, we write 3s2, 3p1. You can write the electronic configuration for any element in this manner for shorthand method. I don't think it's difficult. I'll keep this aside here and I'll discuss calcium electronic configuration in shorthand method. Before that, go to the preceding noble gas for calcium. It is krypton. Not krypton, argon. Argon has how many electrons? 18 electrons. 18 electron has a configuration 1s2, 2s2, 2p6, 3s2, 3p6. This is argon. Now I'll write electronic configuration for calcium. I said calcium. Calcium has 20 electrons. For 20 electrons, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6, we have 4s2. 4s2. Am I right? 2, 10, 12, 16. Yeah. After 3p, you don't go to 3d because 4s is overlapped. Now what can I do? If you write the electronic configuration for calcium in shorthand method, open a bracket and write argon. This argon is to represent the electronic configuration part of argon here. up to 3p6, isn't it? And afterwards, we can write 4s2. This is exactly how we write electronic configuration for elements in shorthand method. This is shorthand method electronic configuration for aluminium. Here we can see shorthand method electronic configuration for lithium. And here, finally, we discuss shorthand method of electron configuration writing for calcium. Probably, if I add some colors to this, it can be seen very clearly. See how simple the work is. Let's have a look at this electronic configuration writing in shorthand method. I explained everything earlier. Now, in this method of writing electronic configuration, see this carefully. The part of the electron configuration of a given element, which represents the electron configuration of its preceding noble gas in the periodic table, is replaced with the symbol of the noble gas. Okay. How do you write electronic configuration of sodium in shorthand method? First, you write sodium electronic configuration because it has 11 electrons. We can write 1s2, 2s2, 2p6, and 3s1. The preceding noble gas for sodium is neon. Its configuration is 1s2, 2s2, 2p6. Therefore, we can write the electronic configuration for sodium in shorthand method. Now replace 1s2, 2s2, 2p6 part of sodium with neon because its configuration is equal to this part of the electronic configuration of neon, the sodium. So open a square bracket, write neon, close it, and write 3s1. Very, very simple. Electronic configuration of calcium. First, I write calcium is equal to 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, and 4s2. Preceding noble gas to calcium is argon. It has a configuration 1s2, 2s2, 2p6, 3s2, and 3p6. Because argon electronic configuration is present, in as a as a part in the calcium electronic configuration, I write calcium is equal to argon 4s2. And then afterwards, we had to write the electronic configuration for some elements using shorthand method. Sulfur. Sulfur has 16 electrons. I write 1s2, 2s2, 2p6, 3s2, 3p6, 4. Okay. In this electronic configuration, the preceding noble gas for sulfur is neon. Neon configuration, you can see above 1s2, 2s2, 2p. It's not very much. Okay, it is 6. Okay, 6. Yeah. Now we have 1s2, 2s2, 2p6, and therefore this part can be represented by the symbol of neon. So electronic configuration is open square bracket and write neon, and afterwards 3s2, 3p4. Okay. And we go to manganese. Manganese has electronic configuration. I think manganese has atomic number 25. So its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s2. Manganese electronic configuration is this. What is the preceding noble gas to manganese? That means what noble gas is found out before manganese. The preceding noble gas of manganese is argon. Argon electronic configuration, you can see 1 is here, 2s2 here, 2p6 here, 3s2 here, 3p6 here. This is an additional part. So manganese electronic configuration in shorthand method is written as first argon within square bracket, and we can write 3d5, 4s2. This is the answer. I think I explained this to you clearly, and you have only two things to discuss yourself: chromium and copper. When you write the electronic configuration for chromium and copper, think about the internal electron rearrangement for better electron stability. I explained this in my session for SPDF notation of electronic configuration. This chromium electronic configuration and copper electronic configuration I explained very clearly. So you had to see the session of writing electronic configuration in SPDF notation to get initially the electronic configuration of chromium and copper, and afterwards it's a matter of just replacing the part of the noble gas, part of the electronic configuration of chromium and copper that represents the electronic configuration of the preceding noble gas. Replace that part with the noble gas, and you can finish the work. Okay, with that, I think I'm supposed to finish this lesson.